Yay! Guess what? We get to do more calculus. You just made it through all of Unit 1. You should feel super proud of yourself. If you can pat yourself in the back, you should do that now. If you're like, you know what? I just want to give myself a high five. You can do that now. Oh, did you see that? I just gave myself an asymptotic high five. It's like this. Or it could have been like this or something else. Okay, let's do this thing. Unit 2. Woo! We're in this together. Let's do this thing. Okay, so I am going to do daily lessons, and I'm hoping that we can get the whole way through 49, but I'll see how long this is. Do 46 through 49. And so you should be taking notes right along with me, know the drill by now. But today, we're going to talk about the derivative. So the calculus is broken up into limits, which is a little part of the year, derivatives, which is a lot of the year, and then integrals, which is really just derivative backwards. And you're like, that word sounds really big and scary. But a derivative is just a slope, and we're going to talk about how it's just a slope and really dive into that today. Okay, so today we are introduced to the concept in which we will spend our greatest amount of time investigating in this class, the derivative. So this word you're going to get used to hearing a lot. This is the answer to most questions in this class, is the derivative. So if we draw this picture together, so let's say this graph's going to be really good. And ooh, look at how good that is. We could have arrows on the end or not. It doesn't matter. Okay, so what I want to find is this. What I want to find is the slope at an individual point. And if you go back to, I don't know, Algebra 1, you're like, I can't find the slope at an individual point. In order to find the slope of a line, I need 2 points. So I can do the change in y over the change in x, or I can do rise over run, something like that. And you're saying, maybe I can go from one point on here to another. But if only 1 point touches this, which if you remember from way back when in geometry, this is called a tangent line. If I want to find the slope of a tangent line, a line that touches a curve one place, like right here, it actually can intersect it more than once, but we're going to call it a tangent line because it acts very similar to that on a circle. If I want to find the slope, I actually can't just find it with 1 point. So what I do is I'm going to draw another picture. This is the same one. You can tell because it looks exactly the same. And if I want to find this here, instead, if I wanted to find, let's say this was the slope of the line at x, what I'm going to do is that I'm going to find something really close to it instead. And I'm going to find the slope of this line. So instead of just finding the slope at x, I'm going to say, well, I'm going to go a little bit further than that and say this is x plus a little bit more, plus h. And you can see that these two slopes aren't exactly the same, but this is going to be a really good estimate of what this one is. So picking 2 points that are really, really close. Okay, so let's think about this. If I have, I don't know, let's say y2 minus y1 over x2 minus x1. Let's write this over on the side, what that would be. So y2 would be, if this is my function value up here, so this is my y, this point is going to be x, f of x, my input and my output. This would be my x1, y1. And then for the second point, I would have x, f of x plus h. Oh, sorry, I should put x plus h in here. Sorry, my x value would be x plus h. I know it's hard to see, but this is not an exponent. It just says x plus h. I just wrote it weird. This would be f of x plus h. So this would be my x2 value and my y2 value. So if I say y2 minus y1, I would say y2 would be f of x plus h, coming from here, minus my y1, f of x, over x2 minus x1. So x plus h minus x. So what this represents to is this is my slope. But you know what they always say, if you can't come in first place, you come in second place. So while this is a tangent line, because I'm seeing where it touches a circle one place, if you remember from geometry, from way back when, probably in middle school for many of you. If a line touches a circle twice, or in this case a function twice, we call it the slope of the secant line. So, and here, this would be the slope of the secant line. And if I simplify this, do you see how in the denominator I have x plus h minus x? So really, I just have f of x plus h minus f of x over h. And so now I need to think about this, because right now, this is a decent approximation for whatever the slope would be over here. But what would make it better and better and better is if these 2 points got closer and closer and closer and closer together, infinitely close. Oh my goodness, are you thinking, I hope I get to use limits on this? If you are, eek, you do. Okay, so if I go down here, if I'm saying the distance between the x value and the x plus h approaches 0, so I want to get this infinitely close together, so this h gets closer and closer to 0. I'd write it like that, the limit as h approaches 0. Eventually, that secant line is going to turn into the tangent line. So the secant line will get closer and closer to becoming the tangent line, infinitely close. These are such big ideas that we're doing right now. I bet you can feel the energy and you're like, I'm so excited about this. Me too. I'm excited also. So the secant line will get closer and closer to becoming the tangent line. And so here I've got the limit as h approaches 0, and I've got this function. What does this represent? If I'm getting infinitely close to 0, we can actually say this is the slope of the tangent line. The slope of the tangent line is also known as the derivative. Woo! We did it. Okay, let's actually try this then. So if I have a function like this, and I said the limit as h approaches 0, f of x plus h minus f of x over h, I'm going to substitute everything I can. So limit as h approaches 0, f of x plus h. So everywhere I see an x, I'm going to substitute x plus h instead. So over here I'm going to write negative x plus h minus 4 times x plus h plus 1. All of this is f of x plus h minus f of x. Be really careful here. You have to make sure that you put some sort of grouping symbols, parentheses, something like that, because you're subtracting this entire f of x. If you don't put the grouping symbols, you might forget to subtract and distribute that negative through over h. All of this looks so pretty. And now we get to simplify it. So now we have to do some work. So I'm going to say the limit as h approaches 0. And, ooh, I almost forgot. Look, do you see how this has a squared here? I should probably put that there. There we go. So somewhere over on the side, maybe at the top, maybe some other location, you're going to write x plus h times x plus h, which is going to be x squared, if I'm distributing all of these terms, plus hx plus hx plus h squared, which is the same thing as x squared plus 2hx plus h squared. And this is all negative, so I'm going to make it negative x squared, negative 2hx, negative h squared. I'm going to distribute this negative through here, so I've got negative 4x minus 4h plus 1. I'm going to distribute this negative through to all of these terms, so I've got plus x squared plus 4x plus 1. Oh, I'm sorry, minus 1. There we go. All over h. And the whole reason why I'm simplifying this in the first place, I guess I should have said that, is because whenever we're finding the limit, you know the very first thing that we have to do is try to substitute in h is 0. And when I try that, oh no, I divide by 0. It doesn't mean the limit doesn't exist. And in this case, it doesn't even mean there's a hole or something else happening there, because it's h is approaching 0 and not x in here. H is just like the distance away from an x value. So it doesn't even mean that. It just means we need to work to simplify to get us out of the denominator. So when you expand all of these terms not only does it look really cool and people are going to think you're smart, but things start happening nicely and cancel out. So I've got negative x squared canceling out. Anything else? Negative 4x, positive 4x, 1 and negative 1. So I would have the limit is h approaches 0 of negative 2hx minus h squared minus 4h over h. Okay, this is nice because now in the numerator, I'm going to say the limit is h approaches 0. I should have given myself some more room, but that's okay. I'm going to factor out an h, and I get negative 2x minus h minus 4 over h. Now I can simplify, now I can substitute. H is 0, right? So I'd have negative 2x minus 0 minus 4, also known as negative 2x minus 4. And you might be saying, what in the heck does that mean? Why would a slope be negative 2x minus 4? Well, a slope of a line, if you think about which in this case is a quadratic function, this is going to be a parabola and it's going to be this way. That slope, wherever you are on that, is constantly changing. So we need a function that I can substitute in different x values. What this is called is the derivative. And the way we denote it is by saying that this is f prime of x. Okay, now let's use it. So going on to the next page. Oh, I'm so excited. We're using our result from the previous page of f of x. And here it is. We know we did this, right? F prime of x is negative 2x minus 4. And so now I'm going to actually show you what this means. So if I would substitute in, let's say, negative 4, f prime of negative 4 would be negative 2 times negative 4 minus 4, which would be positive 8 minus 4. Like, okay, well, what does that mean? Remember, derivative is just a slope, and it's a slope at a particular value. So if I go to negative 4, and I'm finding the slope of my tangent line, that's just what a derivative is, and I'm going to say this about 1,000 times throughout the year. The slope of the tangent line, so I'm going to negative 4, a tangent line would touch once. So if you're like, okay, here I'm touching once at x equals negative 4, which, by the way, this graph isn't labeled. Let's do that. This is f of x. So I'm touching once. If I go up 4, 2, 3, 4, right 1, or down 4, 3, 4, left 1, that is a thing of beauty. Look at that. I just made a tangent line and it has a slope of 4, which means at this particular location on the graph, at x equals negative 4, my graph of f of x has a slope of 4. Let's do another one. How about at negative 2? F prime of negative 2. And then I'm going to go up here, negative 2 times negative 2 minus 4 would be 4 minus 4, and then I get, 0. Okay. But if we go to negative 2 over here, I can see that at the very tippy top of this hill, this relative maximum on this graph, that if I had a slope of 0, I'd be going up 0, rising 0, running, I don't know, 3. So if I go up 0, right over 2 or over 3, or if I go up 0 and left 1, it gives me a slope of 0. Hey, we're good. That is the slope of the tangent line at a place like that, at a maximum. Let's do another one. F prime of negative 1 will be negative 2 times negative 1 minus 4. 2 minus 4 is negative 2. Oh, looks like I got a message. Okay, at negative 1, I'm going to go up to my graph, and I'm going to make a point, and I can see if I go down 2, right 1, or up 2, left 1, so a slope of negative 2. That line wasn't as good. I was getting cocky because my other ones were so good that I was feeling good in my mind, but that's okay. I can see that I just created a tangent line, and my slope of my tangent line is negative 2. The derivative is the slope of a tangent line. So even though it was this crazy function to begin with, if I'm substituting in individual values, it's going to give me the slope at those locations. Okay, And it says, now using your line, draw this tangent. We already did this at x equals -4, -2, and -1. I did this as we were going through. If we're looking here, the derivative function represents in the terms of the graph. So I already just told you this, but just in case this video is getting kind of boring for you and you're like, oh, I zoned out, come back now. What do you think this is? Did you say the slope of the tangent line at given x values? And so if I'm talking about the definition of derivative and what it represents graphically, I can speak. I'm going to say the derivative of the function f with respect to x. All that means is there's some input of x, you get out the function f. So like just a function notation. So the derivative of the function of f with respect to x is the function whose value at x is, and then we can say this is f prime of x equals, the limit is h approaches 0, f of x plus h minus f of x over h. Because remember, this came from that original formula, the y2 minus y1 over x2 minus x1, and those points were getting closer and closer together. And then I'm going to say, given that the limit exists. There are still going to be times when a slope doesn't exist. And we'll get into that more later. Okay, so formal definition. This is what you have to remember, that f prime of x is this whole mess. So now let's try this. It says find the equation of the tangent line f of x of each of the points below. Then draw the tangent lines on the grid above where f of x is graphed. So I'm going to need some other colors for this. Actually, I'll just go with green for a second again. Equation of the tangent line at x equals -4. So at x equals -4, oh, I used black before, I'll still use that. Now we're doing something that you probably did a very long time ago in algebra, but we're just putting this all together. If we're doing the equation of any line, there are two things that I need for it. I need a slope and I need a point. Many of you, your natural inclination will be to put this in the form y equals mx plus b. I'm telling you, you should try to get out of that habit as soon as possible, because point slope form is going to be your friend when the slopes or the points are really crazy looking. So what I want you to know is y minus y1 is equal to m times x minus x1. It's a formula you may not have heard for a long time, but it's going to be your friend. So at x equals -4, I need two things. I need a slope and I need a point. My slope of my tangent line is going to be f prime of -4, which we said was 4. My point is going to be f of -4, which if I look at the graph, f of -4 was 1. And so I'm going to say y minus y1, which would be 1, is equal to m, which is my slope, times x minus x1 minus negative. This is it. You can leave your function just like that, or you can leave your equation just like that. That's all you have to do. If you wanted to change it and you're like, I know that this is 4x plus 17, you would still be correct to do it that way. It just would take more time, and yeah, you don't want to do that later if the slope is this crazy number. Okay, the next one, equation of the tangent line at x equals -2. Two things that you need. You need a slope. This is the slope of the tangent line. And you need a point. Another email. I'm very popular. That one's just junk mail. F prime of -2 would be 5. Oh, wait, I'm sorry. That's f of -2 is 5 because I'm looking at the graph. F prime of -2 is 0. Okay. So I'm looking above because this is always the slope of the tangent. This is always the point just from the graph or whatever function is given. So I'd say y minus y1 is going to be my 5 is equal to m, my slope of my tangent is 0 in this case, x minus x1. You can change this to plus positive. You could simplify this into the line y equals 5 if you wanted and do that work, but you don't have to. You can leave it just like that. Okay, one more. You need a slope and a point. So I want f prime of -1 and f of -1. I know my values, f prime of -1, if I go up to the top again, was -2. F of -1 is, my function value at -1 is 4. So I'm going to say y minus y1 is equal to m times x minus x1. And you have your equation of your line. You did it! Okay, still moving right along, because I think I'm going to do one more. I know it's getting a little bit long, but I'm going to do this anyway because I can. Do I want to? Okay, I'll make a second video, but I might be posting the same day. We'll see. The next thing we're going to do is here. So I guess I'm going to change this, and this is going to be only 46 and 47. But you might have to watch 2 videos. We'll see. Okay, thanks so much. I think you're awesome. And when you think of derivative, you should think slope of the tangent line every single time. Derivative is slope of the tangent line. And if I say slope of the tangent and you're thinking derivative, we're like one mind. If you're not, you're going to get there, and I'm going to keep asking this. Derivative, slope of the tangent, derivative. Thanks so much. I think you're great. I'm so lucky to teach you. Bye.